Professor Ganesh, should I begin?
Hi, Ashish here.
Hi, Ashish.
Hello.
Hi. You can hear me? Can you hear me, Ashish?
Yeah, I can hear you.
Okay. So I was just waiting to see if Professor Ganesh is able to hear me, and then we could give updates. Yeah. So the last meeting, what we had discussed is that Atharva focuses on identifying the SUV in each pixel of coronal sections of the images. So he started with open access images, and then Ashish, along with Umesh, provided us with the data of 2 patients from TMH. So Atharva has been working on it, and what he has done. So basically, what we are focusing on right now is to go through the coronal sections of the PET images so that we can identify the pixel value or the pixel intensity value in each pixel of a coronal image. And then from there, we will calculate the activity concentration in that pixel. So this is something that Atharva has been working on, and he has been able to extract the pixel intensity value. And now we are actually looking towards calculating the activity concentration in each pixel, which is given by a particular formula. So there are 3 components of this formula. It is pixel value multiplied by image scale factor or the rescale slope multiplied by dose calibration. So we have a specific question for Dr. Ashish that the pixel intensity value is easy to extract, which Atharva has done. And the rescale slope is something that is available from the metadata of the DICOM images. We wanted to ask Dr. Ashish, from where does this dose calibration data come from? Is it available in the metadata of the DICOM image, or can be calculated from the metadata of the DICOM image? Dr. Ashish?
I'm not sure
Hello.
if he was able to hear at all.
No, he was. Ashish, you able to hear us?
Yeah.
Yeah. So did you get my question?
No, can you repeat, please?
Yes, I will share my screen.
Yeah.
And
Athar or Professor Shishit, maybe Athar can also show the output as well.
yes. So I will just quickly share something, and then Athar will show the output as well. Okay.
Okay.
So yeah. Okay, I can't share for some reason my screen. Can somebody give me
Just a second.
Yeah. Perfect. I can do it now. Is my screen visible?
Yes. Yeah.
Yes. Yeah. So this is what we are basically trying to measure, right? We are basically trying to first identify the SUV in each area of interest, which is measured by the activity in the region of interest divided by the injected dose and body weight. So through programming, what we basically first have to calculate is the activity concentration. I hope you can see my mouse. So so we have to find out the activity concentration in the region of interest. Now, right now, let's forget the region of interest. We're looking at a particular pixel only in a coronal section. Okay, in an image of a coronal section, we are going to look at in the image of a coronal section, we can look at each pixel. That is what we had decided. So to find the activity concentration for in a pixel, what we need is the pixel intensity value, and which is multiplied by image scale factor and dose calibration. So now the pixel value or pixel intensity intensity value can be extracted from the PET images, which Atharva has been able to do. The image scale factor, if we are not mistaken, and you can tell us that the rescale slope is something that can be calculated from the metadata of the DICOM image. We are actually wanting to know how to get the dose calibration, whether can it be taken from the metadata of the DICOM images, or it is something that has to be provided by you. Once we have all these values, we will be able to get the SUV value, which is measured here. So once we have the activity concentration in the pixel, we'll be able to identify the SUV for that particular pixel using this formula, and then we can identify the SUV max. So this is where we are right now. And I would now let Atharva show the code.
Yeah, I'll just share my screen.
Yeah.
Yeah, so this is the code. First, we read the DICOM file. These are some of the information which we get in the DICOM file. Using this, we get all the things which are required to calculate SUV, like convert pixel intensity to SUV. And then this is the image which we get after saving it in grayscale.
So this is the image that you generated after extracting the pixel intensity value, right?
Yes, yes.
Okay. Ashish, the next thing
Just
for
one
us.
question.
Yes.
Is some normalization required here or no?
So actually
it is normalized.
It is
So
normalized just for demonstration, just for visualization.
I have one
Okay.
question here.
Yeah.
This grayscaling is based on intensity in the pixel or SUV, what you have calculated?
This is intensity based, right, Atharva?
yes, yes.
Yeah.
Yeah. Okay.
We have to come to we want to calculate the SUV in each pixel. And that is what I was saying before, that there are three factors that go into calculating the SUV, which is the pixel intensity value, the image scale factor, and the dose calibration. Now, the thing is, I think we can extract from the DICOM metadata the image scale factor, which is also called as the rescale factor. What we need your input from specifically, as per your domain knowledge, is the dose calibration data that is required for calculating the SU or calculating the activity concentration in MBQ, right? So where does this dose calibration information come from?
That I think there is something called a time of administration.
Okay.
Then time of imaging.
Time of administration and time of imaging. Okay.
Yeah. So because we are using FDJ, so half-life is 110 minutes.
Right, 110 minutes.
So
Half-life.
based on that, we'll have to do this backward calculation.
Can you share? Can you give us some link to the formula, so that because all this information is there in the metadata.
I can send you the formula. I can send you
Fantastic.
the formula.
One more thing,
It's just like just like A0 is equal to this A is equal AT is equal to A0 e to the power minus lambda t.
Yeah, you will have to send us a paper or a formula, and that would
No,
be
I will send you the formula itself. Need not to go in that.
fantastic.
I will send you the formula.
It's already
Yes.
here, but we just have to ensure that it is in the DICOM file as well. You can see in line number 32, there is this injection time and there is also scan time.
I think here they have just like injected dose decay is equal to injected into decay. The same thing.
Yes, yes.
Okay, so this
So is this the formula on line number 40, correct?
Yeah.
That's the formula.
SUV.
no, that's not the formula for SUV. That's not the formula for SUV. That's formula for dose calibration.
Formula to do back calculation.
For dose calibration, right?
Yeah.
So if we look at line number 40 and line number 43.
I think here everything is given. That
Yeah.
So it's already there. You need not to do anything. Yes.
Okay. So quick question, Atharva, if you could just stop sharing your screen so that I could share. Yeah. So again, I go back to the paper that I was showing, and Dr. Ashish, for this equation number 2, the dose calibration, on which line of the code that Atharva was just showing does it come from? That is the question.
Yeah.
So I'm asking you this question right now is, how do we calculate dose calibration? And because you just looked at the code that Atharva was sharing, can you tell us from where does the dose calibration come from the code that Atharva was just sharing? And I'll let Atharva put his slide.
I will show you. It was there. I just saw it was there. Yes.
Exactly. So I will tell Atharva to share his screen right now. Yeah. Atharva, please share your screen.
Yeah. Just
Yeah. Ashish,
can you see under that this?
Just tell us the line number. Just tell us the line number.
Line number is 46.
46. Okay. Okay. Is that the dose calibration?
Yeah.
The decay. The decay is the dose calibration.
So that is decay you have calculated, and just you multiply that decay with number whatever you have, and you will get that.
Okay. Got it.
Yeah.
Got it. So, Professor Ganesh, now what will we have once Atharva implements this is that he will have.
I have one more question here.
Yes.
At the very first place, why do we need to calculate SUV?
Because we will then calculate the SUV max from the image. So we'll first need SUV for every pixel.
So even we can just calculate intensity max. How it will be different than calculating SUV max?
Because we will use the SUV max data into the future input variables for risk factor stratification. That's why
I think Dr. Ashish has a different question. Why not just take intensity max? I think intensity max will not factor in the uptake, right? So I think that's why we want SUV max. Isn't that correct, Dr.
Yes. I think the intensity max will give us the maximum intensity in the pixel, but it is again dependent on the weight of the patient. The SUV max is dependent on the weight of the patient and the uptake of the tumor of the FDG. All these things have to be factored in to determine the SUV level, right? And that's why coming to the SUV max would be more of a priority than just looking at intensity. Is it okay, Ashish?
I think fine, but I don't see this relevance of doing that. If we want to do something like, because ultimately more or less these things are same. Only thing that in SUV you get some sorts of this impact of the weight of the patient and nothing else.
Yeah, but that would be critical depending on, for example, this will be critical depending on the metastasis site, right? If the metastasis site is different, the weight of the patient plays a very critical role for the SUV max level, right?
I didn't get you. I don't think so.
Okay.
I don't think so.
Okay, so anyways, we will have both the values, right? We will have the intensity value and we will also have the SUV max value. So that should not be a problem. So the idea is that
I think we can have both. I completely agree. From a machine learning perspective, more the merrier in some sense. Maybe we find that some of these are more signal, like maybe intensity has more signal than SUV, as Dr. Ashish is anticipating.
Yeah. So this is kind of sorted now. Atharva will commit the code today. And then we will be looking at the next step. So first we will be looking. So the idea is that this is the idea that we are currently following, Professor Ganesh, is we are looking at the SUV levels for each coronal section. We'll try to find the maximum intensity and then correlate it with the coordinates of the CT scan images to find which specific organ it is highest. That is the next step that we are looking at. So Atharva's next job is now to actually segment individual organs, right, Atharva?
Yes.
Venkat, do you have any inputs on this? So this is me thinking that the next job is to find which specific organ the metastasis is, or which specific organ the the highest SUV levels we see. Venkat, before that, do you see any intermediate steps that need to be done?
No, not before that, but where sphere will come in is there will be a conflict of SUV between organs and metastasis. So
right.
The sphere labeling functions will tell us what would be the difference. So there are different combinations. There could be metastasis, there could be organ, there could be metastasis within an organ where SUV will be different. So for each cases. So we will be having labeling functions for each of this and see if we can filter. And our goal is to detect the metastasis alone based on SUV.
Right.
And what would be the range? So the
thing is also going beyond what Venkat is saying. Would the histopathological data, obviously not beyond qualifying what Venkat is saying, he talked about usosphere largely. Also, so far we have discussed the usosphere largely in the histopathological data, right? Identifying Steinberg cell, for example. So can that not have some correlation or some insight into the organ? So Dr. Shidit, that also goes back into our interleaving multiple modalities here, right?
Right. So actually,
would one modality suffice at all?
So no, actually, the idea is that Akshit is also on call, right? So the idea is that Akshit will work on the Reed-Sternberg cells and the microenvironment of the histopathologies slices. And all these features will then be combined together in a multimodal manner for prediction of good or bad outcomes on the two treatments that we have been instituting. Yeah. So Akshit is actually going to commit.
The two will be, we anticipate correlation.
Yes, I would anticipate correlation depending on, for example, if there's a metastasis in the liver, I would anticipate the histopathological slices of the liver, for example, to have more microstructural information, microstructure information changes that we observe in histopathology of liver. That's what I would anticipate.
And metabolism might metabolic organs might reflect more in the transformation, right, at the histopathological level rather than any static. So there could be static and dynamic information from the histopathological data. So again, I'm just thinking aloud.
Yeah. So when you say metabolic information, there will be certain organs that we will probably have to exclude, which already show high metabolic uptake. Like for example, brain. And this is actually exactly where Venkat was chiming in about being able to use peer to differentiate. For example, if there is a metastasis in the brain, brain by itself has a high uptake of will we have high HCV because it is the most highest utilizing glucose utilizing organ in the body. So then we will have to utilize peer to differentiate between a metastasis and a normal brain uptake. And that's where domain knowledge of Dr. Ashish will come in to develop labeling functions.
Domain knowledge and also the ability to deal with very less label data. We won't have label data. That should not be a disqualification for us.
Right.
Sometimes a lot of label data also creates bias, which we can avoid.
Right.
Sir, in fact, in one of the discussions with Raja, what we are trying to do is, instead of having a label data, can we align the IOUs from the labeling functions with the IOUs detected with the end model? That is one of the things. So it's not like we need labeled data. We will be assessing the performance of the labeling functions based on the object detections IOUs and correct the labeling function such that there is a correlation. So this is the next step that we are trying with Raja actually. So based on, we are trying to have a probability-based score for like snorkel or sphere. We can have an IOU-based alignment such that you don't need label data, but labeling functions aligned towards the end object detection model, and that will have a better results.
May I suggest that we actually create the large architectural diagram? Dr. Siddesh,
Actually,
you can,
yeah, actually Venkat has one, right? Venkat
okay.
has one, right? Venkat?
Because if we can flash that, because I don't know if everyone is on the same page, sometimes flashing that helps. And then maybe some people are not on the same page for valid reasons. We may be course corrected.
Yes, right. So can I get the sharing rights as well? I don't know why it's usually not by default.
Everyone have given sharing rights. Okay, let me just. Where are you? Okay. Oh,
I think it's 3000 something. So this is very crude. I'll try to make it more.
The sharing, right?
Yes, sir.
And Venkat, we could actually make it more refined at 5 p.m. when we meet, right?
Yes.
Or unless you're super busy and we do it some other time, not a problem.
No. We can do it then. I mean that during that meeting we can do, but I don't know if it needs to go through a bit of iteration. We can make it beautify this for now. The other one, what we wanted to do is this. So here is a larger diagram that we had. So you have, of course, from the whole slide you have a patch, or it can be even PET CT scan, which I have not added here. Instead of having ROI selection and sphere as two different things, we are trying to merge this into one, where the alignment with the end model such as YOLO or for mask RCNN can be in tune with the labeling functions that are part of sphere ROI.
Dr. Ashish, is this making sense to you?
Can you repeat?
Yeah, Venkat, do you mind just?
Yes. So, Dr. Ashish, we are using some kind of paradigm of the data programming, right?
That I understood. But what was Dr. Ganesh's question?
No. He asked, did you understand that my explanation now about this architecture?
Not fully.
Data programming, the ROI selection is
Can you repeat, please?
Repeat the ROI selection part.
Yes. So, Dr. Ashish, if you look at here, you can have a patch or landmark, right?
Yeah.
That comes from that comes from the PET CT scan. You do a ROI selection.
Yeah.
That could be a region of interest. Okay? Then you have some rules, heuristic rules that you will say. For example, how did you do it to make those region of interest as metastasis or organ or metastasis within organs? Those rules.
Yeah, understood. Yes.
Then we will also have an end model, deep learning model, that will also be trained to detect the same ROI.
Yeah.
What we will do is we will try to align this heuristics and the end model based on some loss function on intersection of union, because that is like one of the standard, or any other loss functions. Basically, we'll try to align that the rules that we have, heuristic rules that are converted from the observations of a radiologist, does it match? Does it align with the end neural network?
Yeah, understood. Yes.
So this makes sense, right?
Yeah, that is fine. Or we may in initial stage we may do like we just do the this contouring of this area where there is a higher concentration of this activity, and then we label it. So you have already contoured, and then we will label it, means what it is, whether it is metastasis or it is some organ, normal organ, or some like benign etiology or something like some physiological activity. So if we do like that, so we'll be able to this denote it very quickly, because contour is already made for us. So we can do like that, and then we can train based on that.
Great. So this is resonating here. Yeah.
Yeah.
Yeah. Perfect. Yeah. So the next step.
Sorry, I just have to
So
leave
maybe you can talk to Venkat. Venkat, can you leave? You can leave, no problem.
Yes,
I know
yes,
you have a
sir.
meeting.
Yeah.
You can leave. So my only request is, if after you refine the figure, right, Kshitij, you can pin that figure somewhere in the WhatsApp
Yes.
group somewhere, right? So that,
Yeah.
or the slides. Yeah, I think we've been mentioning some slides. And that's also pinned in the description of the WhatsApp group, so that we can pull it up every time and contextualize the discussion. Because what happens
Sure.
is, sometimes we may have someone else join, and again we
Right.
may want to start the same page.
Sure. Sure. So just we will do that. We have a meeting. Akshit, Atharva, Venkat, and I. We have a meeting. So just two more things. I would like to introduce Raja to you. He is the dual degree program student that we have, and he's working with Venkat and me on the problem that Venkat just introduced. So he's been working pretty intensely, making good strides. And so next time he will.
I heard about you, Raja. Nice to meet you. Yes.
And next time he will present the progress that he has done in the last 2 weeks.
Yeah.
So next week he
For
will
the
have
next
that
week,
thing ready.
I will come up with the presentation of the work I have done.
So
Sure. Can Raja be added to that group as well, WhatsApp group as well?
I will do that. I was just waiting for you to tell me, and then I'll do that. Yeah. So the next, so what we are doing for the next thing is, now Atharva will right now was parsing through the individual PET slices, and now he's going to find the SUV max in each slice, and we are going to try and find out the region of interest depending on the gradient of the SUV around the SUV max. So we'll first do that. The second thing is he's going to then parse through. So wherever he finds those SUV max contours, he's going to go through the corresponding CT image to know which organ is it. So Atharva is first going to see if he can identify individual organs through coronal sections. Right, Atharva, you will be working on it next. And then yes, so he's doing also pretty well. And next we'll be able to find out which specific organ it is based on the SUV levels. We'll do one step at a time. The next thing would be
that is almost background knowledge, right? The SUV level determining the organs must be, almost like a library lookup. At least there must be a prior associated with that, right?
Yeah.
It may not be as simple, but at least there would be a prior associated with the organ in the SUV.
Yes, rather, I think he has a code that is available. He's going to customize it to what we are trying to do. So idea was that instead of parsing through the entire CT scan image, we will first find the level of SUV, which is maximum on multiple organs. We'll decide a particular range, and then parse only those CT scan images that that have the highest SUV level. So it's kind of a more efficient way instead of going through the entire CT scan library. So this is what he's going to do, hopefully by the next week of meeting.
Great.
And Akshit is actually going to commit all the code that he has previously developed all the code for the histopath. He's going to commit all the code by this Friday to the repository. And actually, I would request a meeting with the histopathologist from TMH for the microenvironment.
Dr. Subhash, right?
Yeah. So I will coordinate with Dr. Subhash and get more inputs on the microenvironment. Because right now we're just looking at Reed-Sternberger cells, but we would like to look at microenvironment also because I think it provides distinctive information.
Great. Okay, yeah. Dr. Ashish is requesting the GitHub link. I think we'll share it on the group.
We'll share it on the group, Ashish.
So one more thing, Dr. Kshitij, I think I have visited TMH many times. If you can make one visit, it'll be really nice to meet all of them in one place.
Yeah.
I don't know if we can sync up together, but irrespective of me, if you can make a visit, and maybe you can make the visit with Atharva and Akshit also.
Yeah, that's the plan actually. That's the plan. We spoke about it last time with Ashish.
Yes, sir. So that sounds fine.
Yeah, once we have something concrete in both the lines, we'll go and visit so that the visit will also be very productive that way.
Perfect.
Great.
Great. So, Dr. Ashish, can you just check this time? I thought was suggested by Dr. Hasmukh Jain and Dr. Subhash and everyone. Actually, this time we changed the time. So I hope this suits. It's just that they're probably on vacation, right? Dr. Ashish.
When I think I didn't see that where it is.
Wednesday 2 p.m. meeting. We had actually a doodle poll, etc. And then I mean, earlier we were meeting on Thursday. We moved it to Wednesday after a doodle poll, and I actually moved a whole bunch of meetings to make it. So I'm assuming this time works for them because they had only voted for this time slot. Wednesday 2 p.m.
Okay, 4 p.m. Wednesday.
No, 2 p.m.
No, 2 p.m. 2 p.m.
This
Wednesday.
time slot in which we are meeting was as per their consensus. I mean, they had wanted this time, though they had not wanted. But
I think
I made myself available.
Wednesday 2 p.m. is okay.
Perfect.
Right.
For me,
Can you just check once with them, and maybe Umesh, can you please check because or rather ensure that they are all available. Umesh, if you can help coordinate.
Yes. Yes.
So because I've also changed my course scheduling for next semester based on this. So okay
Perfect.
then.
Great.
Thanks then. Are we done? Should we close the call?
Yes, we are done.
Thanks everyone.
Thank you. Bye-bye. Thank you, Ashish.
Thank you. Bye-bye.
Thank you.
Thank you. Bye-bye.
Bye.